Let's start out with this opening exercise. Let's use this approximation that log base 10 of 2, remember that's our common log, and say that equals approximately 0.3010 to approximate the values of A, B, and C. So take a minute and do that on your paper, please. You should be able to use the properties of logarithms that we have learned to answer those questions. We're not using our calculators. Well, let's put it this way. We're not punching in log 20, enter. We're not punching in log 0.2, enter. We're using this property, the fact that log 2 equals this, and we're using our knowledge of other properties of logarithms that we've already learned. So how would I do that? Should I go through the first one with us?
Yeah.
This concerns me. I haven't graded part B of the test yet. This concerns me.
Yes.
So this log 20, how can I rewrite 20? Not 10 plus 10, 10 times 2, right? I want 2 in there someplace, right? So this equals log of 10 times 2. And then what can I do with that log? Who remembers the product property? If I got two things multiplied by each other, how can I split those logarithms up, Sophia? Log 10 plus log 2. And we know log 2 because we were given it, yes?
Yeah.
What's log 10? What's log base 10 of 10? Log roll, ladies and gentlemen. 10 to what power gets me 10?
1.
So 10 to the 1 gets me 10. So this is 1. And then I was given log of 2, which is 0.3010. And this equals 1.3010. Yes, yes?
Yeah.
Yes, yes.
How does 0.2 differ? How can I rewrite 0.2 as a multiple of 2? 2 times what equals 0.2? Or should I say 2 divided by what? How do I read 0.2 if I'm not using the language of 0.2? 2 tenths, right? So how do I write 2 tenths?
2 over 10.
2 over 10 or 2 divided by 10? And then when I'm dividing, this equals log base 10 of 2. Log base 10 of 10. And instead of adding this time, we're subtracting. So then I got 0.3010 minus 1. This is review. That 0.699.
699.
You're doing log of 0.2. That's what you did. We're doing the approximation using our properties of logarithms. You were close, but you're not following the directions. 0.699.
Yeah.
Now, how would I do this one? Everybody do C on their own. There is an exponent. How do I do exponents? Come on, Brett. You've done this all your life. 2 to the 4th is 2 times 2 times 2 times 2, right? So what does that mean? How do I split up times? When I got times things in here, how does that mean I split up the logarithm? How did I do it up here? Everything I'm multiplying by each other gets its own log, and then I add them together, right? So how would I translate that down here? Good. Now, is there a shortcut? 2 log base 10 of 2 plus itself 4 times. Can I write that? Do I have to write log base 10 of 2 plus log base 10 of 2 plus log base 10 of 2 plus log base 10 of 2? Jesse? Oh, gotcha. Do I have to write those things out, or is there a shortcut to that?
Seems like a shortcut. Isn't there a logarithm button?
No, screw the logarithm button.
What?
Screw the logarithm button. We're doing this exercise. We're trying to understand the properties of logarithms, not just use robot overlords.
Yeah, that's a shortcut.
This is the shortcut that I want to teach. I know you know how to punch things into a calculator.
I actually don't.
I do know you know how to do that. But if I have x plus x plus x plus x, what's the shortcut for writing that?
X.
X to the exponent.
X to whatever exponent you.
No, because that's x times x times x times x.
What are we doing?
We're doing x plus x plus x plus x.
So X times.
X times what? Yeah, 4x, right?
Oh.
So if I'm doing log base 10 of 2 plus itself 4 times, what should I write? Four times log base 10 of 2. Would everybody agree that that's log base 10 of 2 plus log base 10 of 2 plus log base 10 of 2 plus log base 10 of 2?
You say so.
I agree with it.
I agree 100%. I helped you on this.
Okay. And then what's log base 10 of 2?
0.30.
Yeah, it's given, right? So this is equal to 4 times 0.3010. And then,
We use our calculator.
screw that, 1.2040. Yes? You don't believe me? Put it in your calculator, see if that's what you get. Do 4 times 3.1010.
If it's not what he gets, though, we all get A's on the next quiz. Down here.
Yeah.
Because
Let's do that.
math never lies. It's either right or it's wrong. So
I'm more interested in your process than I am in right or wrong answers, frankly. So
then why don't we get more?
So did I do it right?
process than our answer?
Oh, I get 0.6.
Don't give me that. Screw that. You guys. All right.
The calculator told me it was 0.6020.
Thank you. 4 times 0.3010 equals 1.204. Thank you very much. Thank you. All right, now.
Wait.
All right, we don't have time to go on this. We got 20 minutes left. What's that? Yeah, you'll get something close to this. Not exactly, but close to that. What's that?
Half.
You mean half?
Yeah, that's pretty close. What did I do this wrong?
Yeah, you did that wrong.
Oh.
You probably did log base 10 of 2. and then took that number to the fourth power.
I don't even know what's going on.
Put 2 to the fourth in parentheses, and then hit enter, and you'll get something really close to this. All right, now, can somebody here explain to me why log base 10 of 1 equals 0? Use the log rule to convert it into an exponential expression. What do I mean by that? Go ahead and give me an example, Zach.
Because anything that's 0 power is 1.
Everything except for one number. 0 to the 0 power is not 1, but
What is it?
10 to the 0 power is 1, right? And this log, the common log, is always base 10, right? So I would justify this by saying, well, 10 to the 0 power gets me 1. Now, what about property 2? Somebody other than Zach, who can tell me why log base 10 of 10 equals 1? Who can tell me why? Again, use the log rule. Nice. Nice. Because 10 to the first power equals 10. Nice. Now, how about this? For all real numbers, meaning any number that you can think of, other than the ones with I in it. Who remembers what I means?
Oh wait,
No?
not real. It is.
I equals square root of 1. So all real numbers means anything except for numbers with that in it.
Yeah.
Okay?
Or the exponential.
So
-6.
just justify log base 10 of 10 to the r equals 1. Or equals r, I'm sorry. So 10 to what power? 10 to what power gets me 10 to the r power?
Any real number?
10 to the r power gets me 10 to the r, right? I'm just saying the same thing in a different way, right?
R times R.
This one's the tricky one. I find this one right here. Number 4 is the tricky one. Now think about this. Think about this. Let's look at this expression right here, the log base 10 of x. What does that mean? I analyze log, and I'm going to write the base in here just to. Okay. Now, when I say log base 10 of x, what am I asking? What's the other word I gave to log? How did I introduce the concept of logarithm? What question did I ask? What power of 10 gets me x? So what power of 10 gets me x? Gentlemen, please. This is the trickiest part of this lesson. Okay? So this is asking me what power of 10 gets me x? You don't know because you don't know what x is. You just know that that's something, right? You don't know that. You don't know x equals 1. You don't know what x equals. And therefore, you don't know what this number is. What's the instructions, Nick?
For any x.
It says for any x is greater than 0, explain why each statement is a property of base 10 logarithms. So I'm not looking for an answer as in a number. I'm looking for an answer as in an explanation. And I'm trying to give you that explanation because you're going to see this. You're going to see this a lot. And you need to be prepared to translate this. So again, log base 10 of x equals some number, right? Now, think about this. I'm taking 10 to whatever this power is. What am I going to get? So 10 to some power gets me x. Now I'm taking 10 to that power.
So you can get X something.
Not x something, just x. So this, check this out. These two things, the 10 to the power of log base 10, those cancel each other out. Those cancel each other out. Just like here, let's see. Just like down here, the log and the 10 to the r, the 10 to the power and the log cancel each other out there. They cancel each other out here. Next year in pre-calculus, for those of you who decide to take it, you're going to learn the concept of inverse functions. And that's going to give you the language that you need to make more sense of this. But for now, I just need you to know that log base 10 cancels out 10 to whatever power. And it works both ways. So, let's do this. Property 5, we've done that. All right, let's apply the properties of logarithms. We're going down to number 7. We're going to apply the properties of logarithms to rewrite the following expressions as a single logarithm or number. Okay? So, remember back on the previous page. Remember back on the previous page with letter C. What did I do with this 4 right here? What did I do with the 2 to the 4th power? What did I do with that 4th power? I moved it out, right? I moved it out into the front.
Yeah.
Okay? If I can do that, then I can do the other thing, right? I can move it back in. So, for number 7, I got 1/2 times the log of 25. So, I got something times a logarithmic statement, right? I can move that back in as a power, can I not? So then how would I write that? I would do log of what? It is base 10. It's all base 10. But 25 to the 1/2 power. Very good. And can you simplify that, Zach? No, because that's 1 over 25 squared. No, what is 25 to the 1? What does 1/2 power mean, Brett? What does 1/2 power mean? Some people would say that's exactly what I asked, right?
No, it's not.
What do you think, Jesse? Yes, it's square root. It's square root. So what is the square root of 25? 5. So this is just 5, right? Nice. And then it's plus log of 4. Now, remember, I could split a logarithm up, but can I crunch it back together?
That's not how it works. I mean, they're like terms, so.
They are like terms.
So should I be able to
Yes. Yes, you are. But how is the question?
adding them?
I can either add the logarithm, so I can take the log base 10 of 5, and I can take the log base 10 of 4, and I can add them together, or I can do something else. I can say, well, this is the log base 10 of 5 times 4.
How can you do that?
Try it. Log base 10 of 5. All right. So when I do log of 5 plus log of 4, I get 1.3010299996. All right? Now, if I do log base 10 of 5 times 4, what do you think I'm going to get? Same exact number, right? Same exact number. So when I want to crunch these logs together, provided they have the same base, they have to have the same base. What's the base of this logarithm? And the base of that logarithm? So I can crunch them together. Because I am adding them, I can crunch them together and multiply those arguments. Okay? Letter B. I have to do the power first. So 1/3 times the log of 8, that's the same thing as log of 8 to the 1/3 power. What's another way of saying 8 to the 1/3 power?
Cube root.
Cube root of 8?
Yep.
And what is the cube root of 8?
2.
2. So this is log of 2 plus log of 16, right? And then I can crunch those logs together. What do I do with the 2 and 16?
Multiply them, baby.
All right, so I multiply them. So I get the log of 32, yes? Do letter C. Do letter C. John, can you use a pencil? Give me like collateral of some kind.
The only collateral I give.
Yeah, there ain't no that.
Same deal.
Yeah, I'm on.
Yes, sir.
I have a question.
Yeah.
So I told them we had multiply to get like the actual like that. Why don't we multiply to get it?
They do.
Oh,
They do.
we didn't use that.
We just. That's not a decimal. That's times.
But like,
So you're right. I should probably write this down.
okay.
Yeah. You're right. I should multiply that stuff out.
I was like,
All right. I'm assuming we got some traction here. What do I write? What's my first step?
You're gonna take that 3 from out front and put it in the parentheses with the 5.
How do I put it in the parentheses with the 5, Andrew?
as an exponent.
As an exponent. So this is log base 10 of 5 cubed, right?
Yeah.
Plus log of 0.8. And then, what's 5 to the 3rd power? So this equals log of 125 plus log of 0.8. And then what do I do?
Multiply them.
Multiply them together. So I get a log of, what'd you say, Ava? Can I simplify that further? What's the base of log?
10.
10 to what power gets me 100? 10 to what power gets me 2?
2. Yeah.
Yep.
You shabby.
Let me look at this real quick. Express the... This is the practice set for this unit. It says express the exact solution to each equation as a base 10 logarithm. What does that mean? I want you to pay very particular attention to the instructions. It says express the exact solution to each equation as a base 10 logarithm.
Maybe use your calculator.
You're going to use your calculator. It even says, Nick,
Yeah.
it even says use a calculator. So you get to use a calculator. But first you got to find out what the heck to put in the calculator, right? So let's think about this. Think about this. I got 11 to a power gets me 12. What power do I take 11 to?
The X power?
The x, what is x? That's the whole thing about finding the solution, right? I got to find x. So how do I undo 11 to the x? I take a log, but I do log base what?
Log base 11.
Log base 11. So I take log base 11 of both sides. So log, and this is how I want you guys to do it on your assignment. Andrew, put please. Do log base 11 of 11 to the x power equals log base 11 of 12. And then, what happens on the left-hand side of my equation? What happens? Remember that the log and the 11 to the x do what to each other? They cancel each other out, so I'm left with what? I'm just left with x. The left side just gets me x. And then I got to figure out what log base 11 of 12 is. Do I have a button on my calculator that does log base 11?
Log button?
That's base 10.
That's base 10 or base e, right? With the natural log. So how do I do that? Who remembers the change of base formula?
I don't.
I don't think I've ever learned that.
Mr. Cook, can you
Log of 12 over log 11, right? What's the base of these red logarithms right here? I'm not writing the base down, so the base must be what? 10, right? So I can do this, right?
Yep.
So let's do that. Let's do log base 10 of 12 divided by log base 11 of, base 10 of 11. So, log of 12 divided by log of 11. And I get this number. Now, if I take 11 to this power, what should I get? I should get 12, right? Let's see if I do. 11 to the answer. Look at that.
Wait.
On my calculator, I can just hit the second key, and then right above this negative sign, there's a little blue word that says ANS.
answer
That
me.
just takes the previous answer. So when I hit this, I'll get 12 there.
How did I never know about this?
Because not all calculators have it.
But all calculators do have the thing that if you just immediately type something in after getting an answer, it just says answer, and then it does the rest.
Yep. So, x equals 1.0362.
Yeah.
And remember, it says to the nearest 1,000. So how many decimal places is that?
3.
3, right? So I can get rid of this 2. And the last thing I want you to do with all these problems is I want you to plug it back in. So when you do it here for letter B, you plug your answer back into 21 to the whatever you got in your answer. And if you get 30, you know you did it right. If you don't get 30, you know you got some work to do. That makes sense? So you have it in a way to check your own work. All right? Now, let's move down to the next one real quick. These are going to be the same type of thing, but what do I have to do with letter A before I can do anything to it? I gotta get rid of this 3, right? How do I get rid of the 3?
Subtract it.
Nah, what's that mean?
Okay, you can divide it away.
Yeah, I'm going to divide it by 3, right? And then it's the same thing as up here.
5.
Okay? So, these are your problems. This is the problem set. It is due on, wow, it's going to be Monday. This is going to be due Monday. It's going to be due Monday. So, translation is, you guys got plenty of time to